So in the quiz, second quiz on Saturday, we have uh, this. This is the answer. Okay, is it visible?
Yes, sir.
Yes, sir.
So in temperature coefficient, we will get the 8.64 ohm. Three resistance 6 ohm each are connected, so we'll get the 2 ohm. Elements which are not capable of delivering energy, so that is called passive element. The total capacitance between the point X and Y, so we'll get the 409.5 microfarad. For this fifth one, you will have 2 microfarad capacitor answer, and for this you have R. Okay. So this is the correct answer.
Hello, sir.
Yes.
Sir, can you solve the fourth question for me? Actually, I am having the doubt in that.
This fourth.
Yes, sir.
Do calculate this parallel connection 400 plus 200.
Okay.
This is parallel means that becomes 600. Okay.
Okay.
Now this 600 is in series with 400. So 400 into 600 divided by 400 plus 600. Tell me the value.
400. Wait a minute, sir.
400 into 600 divided by 400 plus 600.
Sir, 240.
240 and this 200 both are in parallel.
420.
So do the addition.
420.
420.
Sorry. Sorry, 440.
440. Okay. 440. Now this 440 and this 400 is in series.
Sir, 209.52.
209.52.
0.52.
So this is in parallel with this 200. So do the addition.
Okay, 409.5. Okay.
Okay.
Thank you,
Good.
sir.
So now today we'll start our unit number 4, electromagnetics. Okay. So in that we are starting with some important definitions. So after understanding that terms, you will get idea about electromagnetics. So just I am sharing my screen. So you all know about magnet. So magnet that has property of attracting the pieces of iron. Okay. So each magnet that having the poles, north and south pole. We have two types of magnets available, electromagnets, or you can say temporary magnets, and second one is permanent magnet. Okay. Permanent magnet, and second is, we can say, temporary magnet or electromagnet. Okay, this is our unit number 4. Okay, electromagnetics. So permanent magnet that has ability to retain magnetism, over a long period of time. Temporary magnet or electromagnet that can retain uh, its magnetic material, magnetic property or magnetism for certain conditions, like okay, retain its magnetism under the presence of presence of strong magnet, or passing electric current current around magnetic field. So to retain the magnetism for temporary magnet or electromagnetic, it needs strong magnet or it should be electrical current passing through the magnetic field. Okay. So for the both permanent or temporary electromagnet that having the strong magnetism compared to the permanent magnet, but permanent magnet is advantageous as it retains magnetism over a long period of time compared to this temporary or electromagnet. As we have magnetic materials are available or magnets available in different shapes. So you already heard about magnetic needles, then bar magnet, disc magnet, then ring type, and horse shoe type. So these are the various shapes of magnet. Okay. So there are some properties of magnets. So for every magnet, there will be two poles. There will be two poles that is called N and S, north and south. So it is also called dipole. Magnet is also called dipole. Okay. So the magnet always aligns them in north-south direction. The magnet poles are labeled correspondingly as north and south. The lines of force moves from the north pole to the south poles. So whatever there is magnetic lines of force that should be from north to south pole. Like poles repel and unlike poles attract each other. Okay, so these are the properties of magnets. Now we are going for first important term for this magnetism. So that is magnetic flux. Now static charge is completed. Electrostatic. Now we are looking for the moving charge. Okay, this for the magnetic charge. So magnetic flux. So magnetic flux. It is called the total number of magnetic lines of force. Total number of magnetic lines of force in magnetic field is called magnetic flux. Okay, uh, it is denoted by phi. Unit is unit of flux is Weber. Okay, and 1 Weber is equal to 1 Weber is equal to 10 raised to 8 10 raised to 8 magnetic lines, or sometimes it is called 10 raised to 8 Maxwell. Okay, so this is the magnetic flux. Total number of magnetic lines of force. Total number of magnetic lines of force in magnetic field is called magnetic flux. It is denoted by phi. Unit is Weber, and 1 Weber is equal to 10 raised to 8 magnetic lines or 10 raised to 8 Maxwell. So there are some characteristics of these lines of force or magnetic flux. So they have no physical existence. Okay. Then they form closed paths. They never intersect each other. Lines of magnetic flux closer to each other and having the same direction repel each other. Lines of magnetic flux closer to each other and having opposite direction attract each other. They exert lateral pressure. So these are the characteristics of magnetic flux. Then second term is magnetic flux density. So just don't mix up electrostatic and electromagnetics. So you will heard same kind of word. Here we have for electrostatic it is electric flux. Okay, that is sign. Here we have magnetic flux density. In static you have electric flux density. Okay, so that is different for static and magnetic charge. So just not mix it up. So magnetic flux density, it is defined as flux per unit area, flux per unit area at right angle, to flux. So flux density, it is defined as flux per unit area at right angle to the flux. It is denoted by capital B. It is denoted by capital B. Okay, and unit is flux per unit area. So it is the unit is Weber per meter square, or you can mathematically write B is equal to phi by A. So this is your magnetic flux density. Weber per meter square, B equal to phi by A. Then we have MMF. Third is magnetomotive force. Okay, so it is defined as force that tends to establish the flux. So force that we need, force that tends to establish flux through magnetic circuit. So MMF is defined as, or magnetomotive force is defined as the force that tends to establish flux through magnetic circuit. Okay, it is equal to the product of current flowing through the coil and number of turns. MMF is equal to, it is equal to the product of current flowing through the circuit and number of turns. So it is equal to Ni. MMF is equal to product of current and number of turns. So MMF is equal to N into I. So what is the unit for MMF?
Ampere.
Yes, it is ampere turn. Okay, the unit is ampere ton, 80. Okay, now fourth one is generally we are taking ampere for the current where n is dimensionless. Okay, but for this number of tons we are considering it is ampere tons. Okay, for mmf. Fourth is magnetic field intensity. Magnetic field strength, or we can say magnetic field intensity. So it's defined as magnetomotive force per unit length of magnetic flux path, defined as mmf per unit length of magnetic flux path. So this it is denoted by capital H. So it is mmf per unit length. So it is H equal to mmf per unit length. mmf is equal to Ni by L. So what is the unit? It is ampere ton per meter. So it is a magnetic field intensity or magnetic field strength, mmf per unit length of magnetic flux path. Unit is ampere ton per meter, denoted by capital H. Now fifth one is permeability. Permeability. So it is the ability of magnetic material to create the magnetic flux through it. Ability of magnetic material to create magnetic flux through it. Okay, so permeability, ability of magnetic material to create magnetic flux through it. So when MMF is applied to ferromagnetic material, the flux produced is very large. Ferromagnetic material has highest permeability. Okay, so in that flux produced is very large compared to the flux produced in air, vacuum, or non-magnetic material. So it is a permeability is different for the different magnetic material. So it is given by the product of permeability of vacuum and relative permeability of magnetic material. So permeability, that is denoted by mu. Mu is equal to mu 0 mu r. So it is the product of permeability of vacuum or air and permeability of magnetic material. So mu 0 equal to 4 pi into 10 raised to minus 7. Okay, where mu r is equal to relative permeability of material. Okay, so this is the permeability of magnetic material. So that is different for different magnetic material. According to that, it can create or it can produce magnetic flux. Now what is relative permeability? So relative permeability that we have seen, that is mu r. So when the magnetomotive force is applied to the ferromagnetic material, the flux produced is very large compared to the flux produced in air, vacuum, or non-magnetic material. So the relative permeability of medium or material is defined as the ratio of flux density produced in the material. So it is the ratio of flux produced in the material, in the medium or material to the flux produced in vacuum. So this is the mu r. Mu r is equal to flux produced in the medium or material to the flux produced in vacuum. So mu r is equal to 1 for air or non-magnetic material. For air or non-magnetic material, mu r is equal to 1. Okay, so this is your relative permeability. Now next term is reluctance. So the function of reluctance is same to the resistance. Okay, so here reluctance that provides the opposition in the magnetic circuit. Okay, so the opposition offered by magnetic circuit to the establishment of the magnetic flux. So here magnetic circuit that has opposition offered. Okay, so that is called the reluctance. So it is directly proportional to the length of the magnetic circuit and inversely proportional to the area of cross section of the magnetic path. So S is equal to, it is directly proportional to the length and inversely proportional to the area. It is inversely proportional to the area as well as mu 0, mu r. A. So this is your reluctance. S is equal to L upon mu 0, mu r, A, where mu 0 equal to 4 pi into 10 raised to minus 7. Okay, so the unit of this reluctance is ampere turn per Weber. Now permeance, you need to remember this all the terms, so that will be helpful for understanding the remaining contents, and that will be helpful in solving numericals. Okay, so by knowing this terms, relation, and units, you will get the correct answer while solving numericals. Now we have permeance. So permeance is reciprocal of reluctance. Reciprocal of reluctance. So this permeance is denoted by delta. This notation is not fixed. It may vary book to book. Okay, in some of the book, the notation that given differently. Okay, so you can, whatever book you prefer, so accordingly you can take this notation. So unit is Weber per ampere ton. Okay, it is reciprocal of reluctance. So unit of reluctance is ampere ton Weber, ampere ton per Weber. So this permeance is Weber per ampere ton, or 1 upon reluctance, or 1 upon reluctance. Okay, now reluctivity. So reluctivity, or we can say it is specific resistance or specific reluctance. Okay, reluctivity means or specific reluctance is defined as the reluctance offered by magnetic circuit of unit length and unit cross section. Okay, so reluctivity or specific reluctance is defined as reluctance offered by magnetic circuit of unit length and unit cross sections. So we can write this S is equal to 1 upon mu is equal to L by A for having unit length and unit cross sections. So we have S is equal to 1 upon mu only. Okay, this is equal to 1. So this mu is absolute permittivity. Okay, so specific reluctance or reactivity, that is 1 upon absolute permittivity or 1 upon mu. Now relation between this B and H. Magnetic flux density and magnetic field intensity. So the flux density, to get this relation, we know the flux density B is equal to phi by A, that is produced in any material, is found to be directly proportional to the magnetizing force H. So we know B is equal to phi by A. So thus greater the magnetizing force, greater will be the magnetic flux density produced in the material. So here we can also write B is directly proportional to the H, greater the magnetizing force, so greater the magnetic flux density produced in the material. And we know this B by H, by removing this, we can write B by H is equal to constant, that is equal to 4 pi into 10 raised to minus 7. Okay, we can say this B is proportional to the H, or we can write B by H is equal to constant, that is 4 pi into 10 raised to minus 7. So thus in vacuum, air or non-magnetic material, the ratio B by H is constant for air, vacuum or non-magnetic material. This constant is called permeability of free space or magnetic space constant. This constant is called permeability of free space or magnetic space constant, and it is denoted by mu 0. So this mu 0 equal to B by H. Okay, so we can write this B is equal to mu 0 into H. So this is the relation between magnetic flux density and magnetic intensity, where mu 0 is permeability of free space or magnetic space constant, that is 4 pi into 10 raised to minus 7. Okay, so up to this, any doubt for this term?
No, sir.
Okay, so this is the important terms for this electromagnetics. By understanding this, we will go for Faraday's law, Lenz's law, okay, and then we will see statically induced EMF. So in that we will see self induced EMF and mutually induced EMF, and for that we will derive the equation, and we will have some numericals for this electromagnetics. So I will provide you question bank for this. So accordingly, you can prepare this unit. Okay. I hope everyone submitted the assignment. Anyone is left or remaining for submission of assignment? There will be a weightage in evaluation component for assignment submission. Okay. So if anyone is still remaining, then kindly do submit it. Okay.
सर
Yes.
ये पढ़ाने की मेथड
क्या?
बता रहे हो आप पीपीटी अपने लेके
I will show you PPT. Don't worry. I have to add some content in the PPT. That's why I am not showing you on today, but I will show you on tomorrow. Okay.
यस सर
I will provide the material. Don't worry. And I am uploading this video lecture on YouTube, so you can go through it if you are having any doubt for any topics. But please do practice for the numericals for means wherever you have numericals in any units, you have to do the practice. Okay. By reading, you will not get the answer because we will not ask same example, same data of example. We will change the data. Okay. Whatever data that will be given in example in examinations, so that will be uh, not same kind that given in assignment or question bank. We will modify the data and we will ask in examinations. But whatever questions or whatever numericals that we are providing in assignments or question bank, so from that or within that we will ask in examinations. Okay. Same for the theory contents. You'll be asked from that. So those still who have a query in unit 1, 2, and 3, please try to solve it or read out those units. Okay. So our flow of these units, this is now we started this unit 4, then we'll go for unit 5. So from the unit 5, you'll be having AC circuit. Okay. So your uh, your concept and your uh, equations that going to change for the AC. Okay. Now up to this, we are going for the DC portion, but from the unit 5, we'll go for the AC portions. So in AC portions, for the fundamentals or fundamental concepts or the equations for voltage, power, current, that is going to change. Okay. Because in AC circuits, we have three types of load that we will use RLC. Up here in DC, up to R, that mostly resistor is used for the DC portion. So that's why uh, just we are using power equation P is equal to V into I. Okay. But in AC, that is going to change according to the type of load is used, RLC, R, L or C. Accordingly, you will get the power equation, voltage or current equation. Okay, and you already studied this concept in 12th. Do you know Faraday's law? Faraday's law. Anyone? Anyone want to give answer? Only statement. What Faraday that gave the statement? According to the electromagnetic induction theory. Anyone want to say statement of Faraday?
change in change in magnetic flux is proportional to the current induced in a loop.
Current induced in a loop, or we can say whenever conductor cuts the magnetic flux, EMF induced in it. Okay, so that is the first law of Faraday. According to that, whenever conductor cuts the magnetic field or flux, EMF induced in it. What is the second law? So there are two laws that uh, gave by Faraday's. So what is the second law?
Direction is opposite to the direction which it cuts.
So in first law, what is saying? Whenever conductor cuts the magnetic field or flux, EMF induced in it. Okay. Second, the magnitude of induced EMF in a coil is equal to the rate of change of flux linkages. Second law states that the magnitude of induced EMF in a coil or circuit is equal to the rate of change of flux linkages, or you can write this is equal to n d phi by dt. So that is given by Faraday's law, but usually in practice we are referring this is equal to minus n d phi by dt. So that is according to the Lenz law. So that we will see in next lecture what is Faraday's law and what is Lenz law and how this minus sign comes here. Okay, so that is given by Lenz law, but Faraday's that given is equal to n d phi by dt, but it is minus n d phi by dt, that is according to the Lenz law. So if you ask any statement, then you have to write properly. Okay, don't miss or skip any words in between. In KVL and KCL in examination ask, so you need to write the exact statement. You need to use this algebraic word, algebraic sum. If you have written this, then you will get the full marks. So this is important words that Kirchhoff use for this algebraic summation of incoming current or outgoing current or voltage around any closed loop. Okay, so you need to write this exact word in the statement. Okay, and you need to show by examples. Suppose for KCL, so you can draw any circuits or you can draw any junction. Okay, just I am writing this I1, I2, similarly this I3. So you can apply this KCL, okay, for this at junction, and you can show this KCL, incoming equal to outgoing. Same, you can draw any circuit for KVL, and you can solve this, okay, by applying this sigma AR plus sigma EMF is equal to 0. So you need to write the statement as well as you need to write this example. So have you written this or only written a statement in examination? Everyone, have you shown this
Yes.
example?
Yes,
Yes,
sir.
sir.
If
Yes, sir.
yes,
Yes, sir.
if you have written only statement, then accordingly you will get the marks. Okay.
Yes, sir.
So don't understand that if you have written the statement, then you'll get the full marks. Okay. So whatever instruction or whatever data that given to you, so accordingly you need to write the answer. Okay. Same for the numericals. Just read the data properly and just start solving it. Okay. So I am ending my session here. So you may leave this session.
Thank you, sir.
Thank you, sir.
Thank you.